Flack math! Give me some math and I'll give you some flack. Flack math!
Okay, number one. Here we go. The number of bacteria increased 340% overnight. If there were 20,000 bacteria yesterday, how many bacteria were present this morning? So you could find 340% of 20,000 and then add it to 20,000, but half of you will find 340% of 20,000, which is like 68,000, and you will stop there. Did you guys stop there? Half of you?
Yes.
Okay. So what did you do wrong? So that's how much it increased. It increased by 340%. This is a very common mistake, especially when the percent increase is well over 100. You think you're done because, oh, it went up. So that must be the answer, maybe consciously or subconsciously. So right when you see increase by 340%, don't think 340, think 440. Okay, so if I did this is my percent increase. So here's my old, here's my new, here's my percent, here's my number. So you can fill out a table just like that. So the old percent is always 100. So the increase is 340. So you're either going to add or subtract that from 100. So now here's your new percent. Here's your old number, 20,000. It's asking for this. So here's your proportion. So you could just fish method that. Or basically, what is that? Times 200. Right? So this times 200 is, what is it, 88,000? Okay? So you could do it the other way, but it's just, this kind of takes out the middleman and it makes it so you don't have to make a mistake. Okay? So don't forget, if you do it, if you find 340% of 20,000, don't forget to add it. Okay? That was number one. Number two, there are 20 students in Mrs. Cloud's algebra class. On the first test, 6 students scored 90. So there are 6 90s. Okay, there were 10 80s. And there were 4 70s. Okay, so how many total scores is that? Looks like 20. So does anyone do that math? What'd you get? Yeah, what'd you get?
I got 81.
81. Is that what other people got? Awesome. So 81 is the class average. Okay? That's pretty straightforward. You guys think you can handle that? Don't add 90 plus 80 plus 70 and divide by 3. Don't do that, right? Because that's not fair average. There are way more 80s. There are a few more. There's 6 90s and 4 70s. So it's not going to be just average of all 3 scores. Don't do that. Okay, number 3. Cynthia had 9 blankets. She weighed the blankets and found that their weights to be this. Find the range, median, mode, and mean. Do not skip this problem. Don't put a question mark. I will do bad things to you if you put a question mark on this. This is worth 4 points. It's really easy. All you have to do is remember what goes with what. If you can't remember, write it down now. Okay? So first things first. Put in order first. So put that on your test. Put in order first. So I'm going to do that. So help me not miss anything here. So 5, 6, 7, 7, 7. 9, 10, 10, 11. Is that right? And is that it? 9 blankets, right? There it is. Okay, so first thing is range. Range, you can write this down, is max minus min, which is 11 minus 5, which is 6. Okay? Can you remember that? You don't even have to remember it. Just use your notes. Okay. There's range. Median. If it's an odd number, it's just the number in the middle. Median is 7. So it's number in the middle. Or average of the two numbers in the middle. Okay? This is an odd number of numbers, so there's going to be just one number in the middle. So if there's two numbers in the middle, like 7 and 9, what would the median be? It would be 8. Halfway between the two numbers in the middle, which is the average of two numbers in the middle. Mode is most often. Which number appears most often? 7. Okay. 10 is a close second, but it's not the mode. If 10 appeared 3 times and 7 appeared 3 times, what would the mode be?
7 and 10.
Both 7 and 10. Okay. But 10 only appears twice. All right, the mean is the pain in the butt. It's the meanest thing I could ask you to do. That's just the average. So add them up and divide by 9, right? Who did that? What'd you get?
So
Okay.
it all added up to 72, and then when you divide by 9, it's 8.
Okay, is that what everyone else got? Awesome, good job, thank you. Any questions on number 3? This is probably the easiest, if not one of the easiest questions on the test. Don't skip it because you forgot what range was or median was, okay? Write it down, remember it. If you put a question mark, I will hurt you. I said that on the internet, okay? I won't physically hurt you badly, but I will think bad thoughts. Okay, number 4. Some of you are just going to put a question mark on it, and then on the next page, you're going to do the problem just to make me mad. I just gave you an idea. Don't do that either. It will ruin my breakfast. Okay, so we're going to translate and then solve. So this is an English sentence. We don't like English. It's important, but math is important to remember. So 5 3/15. How do you say of in math? Times, how do you say what number? That's your variable, right? How do you say is? And 2 1/5. So in math, we don't like mixed numbers anymore. So let's get rid of mixed numbers. Okay? So I forgot to ask this, but if anybody online has their practice test done already that hasn't already uploaded it, then let me see it, okay? So first things first, mixed numbers are dumb. Let's change it to improper fractions. That's 75 plus 13 is 88. 15ths n equals 11/5. So far, so good? Okay, now how do you get rid of 88/15ths? Yeah, it's being multiplied, right? So how do you divide by fractions? Just do it. Okay, we copy dot flop. Now, do not copy that and do not flop that because you're not dividing 88/15ths by 11/5, are you? You're dividing 11/5 by 88/15ths. So do not flop that. So write the division problem first. If you don't, you're going to flop the wrong stuff. Here's the division problem. So we are going to copy dot flop. Okay, this is nice because we get some cancellations here. Oops, 3. So we just get 3 8s. How beautiful is that? Nice. Okay. All right, number 5. 7 is a member of which subsets of real numbers? Okay, if you don't know the subsets of real numbers, write them down. You've got real. You've got irrational or irrats. You got rats. You got integers. You've got whole numbers. And you got natural numbers. Okay? That's it. Those are the only subsets of real numbers. So what is 7 a part of? Well, it's a part of natural numbers, so that means it's a part of everything above it, right? It's inside the innermost circle. So that means it's not only a natural number, it's a whole number, it's an integer, and it's a rational number. Okay, you don't have to say real numbers because subsets of real numbers, a real number set is an improper subset, so you don't have to include it. Okay, so that's A. What about B here? 7 radical 7. It's got a radical in it that can't cancel. You can't take the square root of 7, so you're stuck with the square root of 7. What kind of number is that? Irrational. Okay, and that's it. If it's irrational, that's the only subset it is. There's nothing above it except the real numbers. Okay. So if you see a radical or a square root sign that you can't take the square root of, obviously if this was 7 times the square root of 4, would that be irrational? No, because the square root of 4 is 2. So that'd just be 14. If you get a radical or if you have pi in there, those are the only 2 things that you, oh, I want pi. If you have pi in there or a radical, it's irrational. Now, they might trick you and say 7 pi minus 7 pi plus 1. Well, 7 pi minus 7 pi is 0, plus 1 is 1. So make sure everything's simplified first and then make your evaluation. And if you're stuck with the radical or pi, it's irrational. That's the only thing that you'll see if it's irrational, okay? So they made it real easy for you. All right, number 6. Graph the following equation on a rectangular coordinate system. Okay, probably shouldn't have put it over in this cute little place here. All right, so we have not talked about, have we talked about slope-intercept form yet? Okay, that's okay. So we just have to pick some x's and y's that'll work. Okay, even though x is on the other side, we're going to list it like this because this is how we're going to graph it, right? X, you go left or right first and then up or down. So give me an x, any x. 0 is always nice. When you plug in 0 for x, what do you get for y? Negative 2. So you get negative, so I'm going to write it up here, negative x minus 2. So you get negative 2. Pick, what's another easy x?
I put negative 1.
Okay, you put negative 1, and I heard 1 and negative 1. Let's do negative 1 first. If you put negative 1 in for x, what does that make this right here? Positive 1. And then what's 1 minus 2? Negative 1. Right? Is that what you got? Okay. What'd you get when you plug in 1?
Like negative 3, right?
Yeah, negative 3, because this is negative, x is 1. So negative 1 minus 2 is negative 3. Good.
I just do the small numbers so I don't have to write a big.
Well, that's a good idea, dude.
Got a 4x4 graph, and it's like it's super small. So it's like just like.
Yeah. All right. So how do you graph 0, negative 2? How do you graph these? You don't have to write them out like this, but this kind of puts it back in familiar territory. What do you do? How do you graph 0, -2? Quick, quick. You just do it. Elkin, what do you do?
Well, okay, so for the x, it's the horizontal, right?
Yep.
So 0 is just in the middle, and
Yep.
then you go down -2.
Boom. There it is. Okay, this is where you'll mess up if you mess up, I think. So make sure you go left to right first. So you're going to go right 1, down 3. Left 1, left, down 1. So this is what this looks like. If you show me that on your paper, 100%. Yes.
Are we gonna get like docked points if we don't draw
Perfectly. Well, draw the line. Yeah.
But like with the arrows, are we gonna get docked?
Oh, no. I mean, just make it a habit.
Yeah.
If you just connect the dots, you're fine, but make sure you draw the arrows too. But if you don't, I won't mark you off. I'll just think bad thoughts. Okay. On the line you're making.
Okay.
I don't care about those.
Okay.
But
There's a
yeah,
lot of arrows in that problem. Which one you talking
yeah,
about?
there's a lot. Okay, graph the following inequality. So first thing, we have to solve this inequality. We solve an inequality almost exactly like we solve an equation. And then what we'll do is we'll not make it a negated. So let's do that first. What's a better way to say this symbol? What's a better way to say that? Yeah, Elkin?
Did you do x -2 is equal than or smaller than
Yep.
0?
Right, so remember there's only 3 options. So we just eliminated this one. So it could be both of those, okay? So if there was a line under there, it would be not greater than or equal to, so you would get rid of that one and that one, so you'd be left with less than, okay? All right, so how do we solve this? Same way we solve anything else. Get x by itself, so add 2 to both sides. So x is less than or equal to 2. Okay? So now, if you're going to mess this problem up, it might be here. So how do you graph this? How do you graph x is less than or equal to 2? What do you do?
Could you draw a circle? Could you draw a circle around the 2, and not the 2, but like the line above it, and then fill it in, and then graph to the left?
Okay, you would if,
Don't you fill in the circle?
yeah, he said fill it in, but you would if the domain was real numbers. So you would have gotten half off because you knew you did everything else right. You graphed it correctly. If they didn't give you a domain, you can assume that it's real numbers, but it's just integers. So what you're going to do is you want to go at least 1 into the negatives there. So you just do that. Does that make sense? Because you just want the integers. Remember, integers are all the whole numbers and their opposites. So -1, 0, 1, 2, 3, all the way to infinity, but nothing in between. So you can't graph anything in between. Okay? So pay attention to the domain. What if it was just positive integers? How would you graph it? Anybody? Just do 2 and 1. Yeah, if it was just positive integers, it would just be 2 and 1. If it was just negative integers, it would be -1, -2, and so on. Okay. Number 8. Here we go. Here's the sets. A is 1, 2, and 3. B is 0, 1, 2, all the way to infinity. C is 0, 1, 2. And that's it. So there's only 3 members of C, 3 members of A, but there's an infinite number of members of B, right? because that ellipses says it goes on forever. True or false? A is a subset of C. True or false?
False.
False, because 1, 2, 3 does not fit inside of C, because this doesn't have a 3. All right. So basically, you have to ask: do all the members in A, are all of those members in A in C? No, 3 isn't. Okay. All it takes is 1 that's not to ruin everything. Is C a subset of B? Are all the members here inside of B? Yep, that's true. All right. What about 1 is not a member of A? Is that true or false? It's false, because 1 is a member of A. So it's right there. So this statement is false. This is where it kind of messes with your head a little bit. Say it out loud and then judge for yourself whether you just sinned. Okay? 1 is not a member of A, and you're looking at it right there. You should be ashamed of yourself for saying that out loud. So it's false. Okay? Number D. Yeah, I said number D. 0 is a member of C. Is 0 a member of C? Yep, there it is. True. Okay. Take these slow. It's easy to go through these quickly and get some wrong, because you gotta slow it down. All right. Same kind of thing. Are all the real numbers? Can all the real numbers fit inside the set of irrationals? True or false? False, right? So we had it here. Remember, anything below the real numbers, anything below fits inside what's above it. So real is above irrationals. So real is not a subset of irrationals. Irrationals is a subset of reals. So that's false. Okay. What about integers? Do all the integers fit inside of the whole numbers? Well, no. Yeah, integers were above the whole numbers, right? If you don't have that little diagram, you should write it down. So this one's also false. Okay, so far so good? You guys feeling good? You guys are going to ace this test. Evaluate. Do not use a calculator. You can use a calculator. But you don't need to use a calculator. You should have these memorized by now. What's the square root of 144? 12. What's the square root of 49? 7. What's the square root of 196? 14. What's the square root of 16?
4.
Good. So there it is. Welcome back to Math 7 or kindergarten. 5 is 19. What is that? 15? You guys good? All right. Number 11. Without using a calculator, determine between what two consecutive integers. So if you use a calculator, if you were to use a calculator, what do you think your calculator would say? It would say something point something. So give me that first something. What's the square root of 55? So what times itself equals 55-ish?
7 and 8.
Yeah, so 7 times itself is 49. 8 times itself is 64. So it's 7 point something. So it's in between 7 and 8. This is the cool way to say in between 7 and 8. So you don't have to do it like this, but this makes sense, right? Because square root of 55 is greater than 7, but it's less than 8. Okay. Any questions with number 11? You good?
Have you been having these on problem sets? Because I don't remember having this kind of problem.
Yeah, it looks pretty, but you did this test, right? It's Algebra 1, test 16, my goodness. Yeah, we didn't really talk too much about it. This is a long time ago.
Yeah.
It was in this class.
Going over it, but I was like, oh.
Yeah, so remember So now all the tests are going to be, well, all of them have always been cumulative, which means that it covers everything that we've talked about this whole year. So Saxon tests get really difficult at the end of the year because it's going over everything we've talked about. Okay. All right. So now we get into the a little bit more difficult stuff. Well, this one's not too bad. Square root of 68. Why does it say simplify? What's wrong with that? There's no square root of 68, but there is a square root living inside of 68. So do this. What is the biggest square that goes into 68? Can you guys think of it? It's not that big. It's just 4. Okay? So this is square root of 4 times the square root of, what is that? 16? No, 17? Okay? So far, so good? So this is the hardest part right here, is putting the square on the left and the non-square on the right. So make sure you look for the biggest square, because then you just do it in one step. Okay, so do a factor tree, but it's not 4 times 17. It's the square root of 4 times the square root of 17, because we're talking about the square root of 68, not 68. So when you multiply two radicals, you get that one big radical. So you can go backwards. You can factor it out. Well, what's the square root of 4? 2. So you just write 2 times the square root of 17, or if you just write it right next to it, that means multiplication. Can you guys handle that problem? Okay, good. All right, number 13. So we're going to multiply. We're going to FOIL it out. Remember foiling? Remember we talked about FOIL? What the heck does that mean? Yep.
Inside, last. There we go.
Okay, so first, outside, inside, last. So first would be 4x times 3x. What's 4x times 3x?
12x squared.
12x squared. Do not forget that squared, okay? If you mess it up, it'll probably be right there. And then outside. Outside of these outside terms, what's 4x times negative 4? Negative 16x. And then inside, what's 2 times 3x? They're both positive. So just 6x. And then the last one, 2 times negative 4. Negative 8. Are you done?
No, because we had like terms, right?
No, now you can, if you do it, if you follow the FOIL acronym, you will always just combine the two middle ones. You don't have to worry about anything else. And it'll already be in descending order. So you don't have to worry about writing it in descending order. So you get 12x squared minus 10x minus 8. It might be hard to see that. You guys see that? There it is. Okay, questions on number 13? All right, let's get crazy with the rest here. The next two are probably the thorns in your flesh. It's going to be a pain, but just do it step by step, because if you look at that problem, it's okay to say, you know what, I don't know how to do that. But you don't have to know how to do it. You just have to know how to do the first step. Because once you do the first step, the second step will make itself known to you most of the time, okay? So let's copy it down. So it's 14. So w, y to the negative 2, z to the negative 1, plus x to the negative 3, y, z to the negative 1. And it says add. Okay. So we can't add these because they're not like terms, right? But if we write them as fractions first, then we can get common denominators. Okay? So right now you can't add these. Like there's no w's in both. right? So you're kind of, there's no x's in both. So you're stuck, like in this mode. But if you write them as fractions, which you can, because we've got negative exponents there, then we can find common denominators. So these guys are negative exponents. They go downstairs. This goes downstairs. This goes downstairs. So let's rewrite this. So what's left on top in the first one? W, okay? All over. Now, when you bring these downstairs, you have to change the sign of the exponent. So this is y squared positive 2, z positive 1. So we don't really need a positive 1, right? Positive 1 exponent, you don't need it. Plus, y is on top, and you have an x to the positive third and a z on the bottom. So how do we make these denominators look the same? What do we have to do? Elkin?
So you could add an x cubed to the left one,
Okay, so I'm going to put an x cubed over here.
and then a y squared on the right one.
And let's put a y squared over here. So
And
can
then
I
you
just
do that to the top also?
y squared, y squared. So now we can add them, right? Because we have the same denominator. They look the same. And you can change the denominator as long as you change the numerator, which is what we did. Okay, so what are we left with on top? Wx cubed plus, what's a better way to say y squared? Y cubed all over our denominator. X cubed, y squared, z. Okay, check the question again. Make sure you did it in the right format. Right, with positive exponents. Yep, we got it. That's it. Can you guys handle that? That's not terrible, right? So first step, write them as fractions, and then find a common denominator and add. Okay? You're going to be tempted to start canceling stuff. Oh, can I cancel? No, don't. You can't cancel stuff because of that addition sign. And you could cancel stuff over here, but that would bring you back to where you started. You're doing the opposite of reducing, right? When you find common denominators, you're expanding the fractions. You're doing the opposite so they look the same. Okay, number 15 is this crazy distribution thing. I think where people get into trouble is they try to do too much at the same time. So don't do that. First thing I'm going to do is I'm going to write this first guy in the parentheses over 1, because I'm just going to distribute the crap out of this. Okay, so I'm going to just multiply this fraction times all these fractions. Don't worry about cross reducing or anything like that. That'll get you into trouble. So just multiply them across. So multiply the tops times the tops and the bottoms times the bottoms. So this is negative. So that means a negative, you're going to multiply in a negative times all these. So it's going to change everybody's sign. So this is going to be negative d to the fourth, b to the fourth, all over b to the fourth. Right? You could just leave it d squared, b to the fourth, and then clean that up later, whatever. But let's do this. So this is minus negative. So we're going to add d to the fourth over b to the, what's this multiplied to? B to the fourth times b to the negative third. Just b, that's right, because 4 plus negative 3 is 1. And then plus, because it's a negative and a negative, 4, I like to put the numbers out front. What's d squared times d to the negative 2? D to the 0, which is just 1, right? So it just cancels. And then b to the fourth does not cancel. That's b to the 8th. Okay, so now let's just clean up all of our stuff here, and then we're done, okay? Don't try to find a common denominator. You don't need to. So it just says expand. It doesn't say add. It doesn't say simplify. It doesn't say doing any of that. So all you're doing is expanding it. Okay. So let's see. This is where some of you mess up. because you forget that, oh, I gotta cancel this. Or you could bring these up if you wanted to. How do we write now? All exponents positive. So if it's the same thing over the same thing, just cancel it. And then you're left with negative d to the fourth. So your answer is negative d to the fourth over 1. So you could just leave it negative d to the fourth plus d to the fourth over b plus 4 over b to the 8th. Is that what the answer key says?
I don't know. I thought the problem said for the first fraction d2 negative 2.
Oh, no, so we wrote down the problem wrong. Sorry. Okay, so.
Like, why are you getting this so wrong?
So that means these cancel, right? So that's d to the 0, which cancels. So what's d to the 0? So it's just 1, right? So it's negative 1 plus d to the fourth over b plus 4 over b to the 8th. Yes.
Since it's then
Negative 2
wouldn't you distribute it to the
others
other ones?
Yes, correct. So that would cancel too. That's nice. But this, you're stuck with the d to the negative 4, right? So then you get 4 over. So there's your answer. That was a mess. Make sure you copy the problem down right. Okay, so these d's cancel, these d's cancel, but this is d to the negative 4th. So, and the problem says make sure you write your exponents positive, so that d to the negative 4th has to go downstairs with the d to the positive 4th. Okay, does that feel better? All right, Audrey was thinking bad thoughts about me. Okay, moving on to 16 here. Okay, this is just a complex fraction. So we're going to copy dot flop z over x times x plus z over y. So that was already a fraction divided by a fraction. We're just dividing fractions. Now, in problems to come, we have to simplify the top and bottom first into a fraction, but these are already fractions. So you can just copy dot flop. Once you have a fraction over a fraction, you can copy dot flop. Nothing cancels. Please don't cancel these x's, right? These x's can't cancel because it's not a fact. X is not a factor. You can only cancel common factors. A factor is something that's multiplied or just by itself. There's nothing being multiplied. So this is a factor. The whole thing is a factor. This is a factor. You can't cancel them. So your final answer, z times x plus z all over xy. You can leave it like that if you want. You can distribute it out, zx plus z squared if you want to on top, but you can just leave it like that. All right, number 17. First thing I'm going to do is bring everything upstairs. This is unlike other problems because everything's being multiplied on top. Everything's being multiplied on the bottom. So you can rearrange however you want. So I'm going to bring everything upstairs. So should I do that? Should I do the parentheses first? It doesn't matter. So let's do the parentheses first. A squared, y to the negative 2, z to the 0. I'm going to leave out. Is everybody okay with that? I'm not even going to write z to the 0. Why not? It's just 1. So multiplying by 1 doesn't change it. So that cancels. And then I'm just going to distribute my exponent. So a to the negative 4, and then y to the 0. Right? I just multiplied the negative 4, positive 4, right? Because negative 2 times negative 2, see the a to the negative 2 up there? So that's positive 4, still y to the 0. And then I get AY cubed.
Wait, do you multiply the
Yep, when you have powers raised to other powers, you multiply the exponents.
Okay.
Okay, and then this would be z to the -4th. This is a rule that's tough to remember. When you multiply things together, you just add the exponents, right? But when you take powers raised to more powers, you multiply the exponents. On the bottom, here's what we got on the bottom. A to the 0, I'm not going to write. Y to the -3 times 0 is 0. I shouldn't have even written that, but oh well. AZ, and then A to the +2. And then Y to the -2. All I did this first time around was apply the power rule of exponents, which means if you have exponents raised to other exponents, you multiply them.
Wait, how did you get A2?
A to the squared,
Yeah.
because -1, A to the -1 times -2.
Oh, okay.
Yeah, so when you have an exponent raised to an exponent, you multiply the exponents. Okay, now what? Well, I'm going to do some Flack magic here. I'm going to bring all this upstairs. So I'm going to ignore the Y to the 0. I'm going to rewrite these guys with negative exponents. Or not negative, but opposite. So see how these guys are written right here with their opposite exponents. So remember, if you don't see an exponent, it's 1. So now it's A to the -1 upstairs, Z to the -1, A to the -2, Y to the negative, or Y to the +2. So now I can just add all the exponents of the A's, add all the exponents of the Y's, and add all the exponents of the Z's. So I get A to the, let's see, I'm going to cancel that out. A to the 2 plus 4 is 6, plus 1 is 7, plus -1 goes back down to 6, plus -2 goes to 4. And then Y to the -2 plus 3 is 1, plus 2 is 3. And then I get Z to the -4, and -1 is -5. Is that what you guys got so far? Okay, now what does the answer say? Write with positive exponents. So what do I have to do to clean this up? Throw that Z downstairs where it belongs. So you can just go Z to the 5th and just write it like that. That works. Okay? That's a lot of details, lots of potential for you to mess that up. Okay? But the concepts are just 3 different concepts that you have to remember. You have to remember how to take an exponent raised to another exponent, how to do that. You need to know how to change the sign when you bring stuff upstairs or downstairs or whatever. And you need to know how to multiply exponential expressions by just adding the exponents. Okay? 3 things, but lots of details within those 3 things. So, show your work, because if you just show me this and it's Z to the 4th instead of Z to the 5th, but everything else is right, it's completely wrong. Because I don't know what you did, and I don't know if you did anything right. You could have just guessed. Okay? So, protect yourself. Insurance. This is math insurance. Show your work. All right, we're going to use substitution. 3x minus 2y equals 12. And also 2x minus y equals 8. So it says use substitution. So substitution means if a variable equals this expression, you can plug this expression in the other equation. Well, we don't have anything that says x equals this, you're welcome, or y equals this, you're welcome. So we have to get one of these 4 variables by itself. Which one looks like the easiest one to get by itself? Yeah, this y down here. So bear with me, okay? I think it's easier to just take this y, put it over here, and take this 8 and put it over there. Because if you put a negative y over here, what does it become? Positive y. And if you put an 8 over here, what does it become? Yes. So basically, we get 2x minus 8 on this side and a positive y. Now you're done. So y equals 2x minus 8. Does that feel okay? Now you could have done it this way, where you go, okay, get rid of 2x, get rid of 2x. So negative y equals 8 minus 2x. But that's negative y, so you have to make that positive. So make everything else, change the sign of everything else there. That's the same thing as that. But negatives just bother me, and they bother you too. So try to avoid them at all costs, okay? Because it messes with your cute little head. Your heads are cute. Mine's cute. There's less hair to make it uncute. Not that you're uncute if you have hair. You're just less cute, okay? All right, we're not done yet.
Wait, we're not done.
So now we have something to replace y. Okay, so we're gonna replace y right there where we see the other y. So we're gonna rewrite this top equation, but with our new wrapper name for y, which is 2x minus 8. Or some of you might have negative 8 plus 2x, whatever, equals 12. So see how I just rewrote that equation with our new name for y? All right. So I'm going to chicken scratch this because I'm not distributing a 2, or am I? I'm distributing a negative 2. So let's make it obvious that I'm distributing a negative 2. So then I get 3x plus negative 4x plus 16 equals 12. So when I distribute a negative 2 to a negative 8, I get positive 16. All right, so that gives me negative 7x. I just combine the x's. Plus 16 equals 12. So negative 7x, get rid of 16. Oh, this is going to be ugly.
How can you do negative 7x? Just positive 3.
Oh, look. You see that little messed up?
I'm like very confused by how you got that.
You're right. I didn't technically make a mistake. I mean, you guys see that like messed up part of the board, right? It looks like a negative 3x. Okay, good. Now it's not going to be ugly. So what is that? Negative x? So negative x equals negative 4. So what's positive x? Positive 4. So x equals 4. Now I can plug it into this one that I got by itself because that tells me what y is. Y is 2 times x, or 2 times 4, minus 8. So what's y?
0.
Y equals 0. So you can leave it like that, or you can do what the cool kids are doing and write it like a coordinate, 4, 0. Is that too cool for you? Yeah. All right. So that is not the only way you can do that by substitution. You could have gotten any of these by itself, but if you would have gotten x by itself, you would have gotten x equals 1/2 y plus 4. That's not pretty, right? Then you have to deal with the fraction through your equation. That's not fun. Okay, so this is the easiest one to get by itself. Look for the most vulnerable variable to get by itself. The one who doesn't have any friends, sits by himself at lunch. It's okay. It's okay to sit by yourself, but this one, we can take them out a lot easier. So if you see some people sitting by themselves at lunch, go sit with them because someone might come and try to get them by itself. That just got really dark and bad. I'm sorry. Okay, number 19. All right, well, we can do this. What's 4 squared? What's 4 squared? What's 4 squared? 16, right? Minus 27, don't say 9 or I'll think bad thoughts. Okay, plus or minus 4. What the heck does that mean?
You have to do both ways.
Right, so you got, so let's just do this first. 16 minus 27 is negative 11 plus or minus 4. So that means you're going to go negative 11 plus 4 and negative 11 minus 4. So negative 7 and negative 15. Okay, can you guys handle that craziness? All right. All right, how do you find the surface area of a prism? So here's what the Saxon Geometry book says. Capital B plus L, which is base, will actually be two bases plus L, right? Because you got the top and the bottom. So if it's a right prism whose height is that and the surface area, find the surface area. Oh, I don't even see it yet. Okay, so you have to find the area of the base plus the lateral area. Well, the lateral area is just perimeter times height. Okay, so if you unwrap that crazy shape, it makes a rectangle, and the length of that rectangle is the distance around that shape, right? Then the height would be whatever it is, 11 feet. Okay, so we can do that. Surface area equals, well, what's the area of the base? How do you find the area of that trapezoid? You guys know the shortcut?
Oh, would you find the triangle
You could.
of it?
The area is 48. Here's why I knew that. That's a trapezoid. So it's the average of the bases. What's halfway between 3 and 9? 6. 6 times 8 is 48. So the trapezoid has an equal area to a rectangle that is basically the base is halfway between the two bases. But most of you, and it's probably better for your brain to break it up into two little sections there. So let's do that. So we got a 3 by 8 rectangle, which is 24. And what's the area of that triangle?
Wait.
Yep, 24, because I know it looks weird. Look, it shouldn't be 24,
Yeah.
but especially the way I drew it.
Yeah.
But that rectangle is pretty skinny. So it's still 6 times 8 divided by 2. Remember, base times height divided by 2. So that's another 24. So you got 2 times 24, or 48, because the total area is 48. So you got 2 48s plus PL. What's the perimeter? 3 plus 8 plus 9 plus 10, right? So 13 plus 17 is 30. 30 times height, which is 11. So you get 96 plus 330. What is that? 426. Is that what you guys got? Square feet? Did you get 426? Did you? All right, good. Okay. So you could do it side by side if you wanted to. If this is like, I don't know what you just did. You could find the area of each of the faces, right? There's, what is there? 1, 2, 3, 4. There's still just 6 faces to that weird prism, but you could find the area of each of those 6 faces and call it good. You're fine doing that. Yeah.
Is there like a limit to how many test corrections we can do? Like, oh, we can only do test corrections 3 times or something like that.
On the same test?
Not on the same test, just in general.
No. There's not a limit. Yeah, you can always do test corrections. Okay, and remember, test corrections you can do up to You get up to 10 points back if you do them yourself. You get up to 15 points back if you do them with me over Zoom. And sometimes I'm nice and do more than 15. Okay, any questions? You guys feel all right? Okay, you're gonna ace this, right? Show as much work as you can. Remember, math insurance. All right, good luck, onliners.
Flack!